Come close, I want to tell you a story. A story on my personal quest to find a real-world linear algebra application. In my 19 years of life, I never yearned for anything more. What would completing this goal give me? Purpose, meaning, 10% of my semester average. Fueled by nothing but pure passion and White Monster, I spent hours of analyzing, researching, computing, all in an effort to show the world the power of linear algebra. Linear algebra consumed my very essence and being. Matrices were quite literally being burned into my vision. She said she needed space, I gave her the 4 fundamental ones. What is Ron Larson's sacred text trying to communicate? After all my weeks of strenuous effort, I finally had an epiphany. The topic for my project, cryptography. Let's begin.
Ever want to write secret messages? Now you can, thanks to the revolutionary Hill cipher. The Hill cipher utilizes inverse matrices that serve as your key and convert
Cryptography at its very core is a lot of math. The sequences and series required to encrypt and decrypt messages are mostly mathematical concepts, and linear algebra is no exception to this. While there are many different types of ciphers, the one I'm going to be looking at specifically in this project is the Hill cipher, which utilizes linear algebra concepts such as matrices, inverse matrices, and matrix multiplication. So how do we encrypt messages using the Hill cipher? Well, we can break it down in a few steps. We first take our plain text, which is the message we're trying to encrypt, and then we convert it into a modulo 26 matrix. Once we have this modulo 26 matrix, we multiply it by our key matrix, and this will give us the encrypted matrix for our message. The modulo 26 alphabet is how we convert letters into numbers. Essentially, we're assigning each letter to a number 0 through 25. A will be assigned to 0, B will be assigned to 1, C will be assigned to 2, and so on and so forth. As a quick example, let's say our plaintext phrase is hi. If we wanted to convert this into a mod 26 matrix, we would just see what numbers H and I correspond to. H corresponds to 7 and I corresponds to 8. Therefore, our mod 26 matrix would be 7, 8. Every Hill cipher needs a key matrix which will be used to encrypt and decrypt the message. A valid key matrix needs to meet a few requirements such as being a square matrix, obeying the mod 26 system, and being invertible. Notice how the example key matrix here is a 3x3 matrix. This means that it will be encrypting and decrypting our message 3 letters at a time. Alright, let's start an encryption now. The plaintext phrase we're trying to encrypt is linear algebra rules. We're going to convert this into numbers, which will then look like this. Again, we're encrypting the message 3 letters at a time. So we start with the first 3 letters of our phrase, which is LIN. This corresponds to 11, 8, and 13. This will be our first plaintext matrix, which we'll call P1. We then multiply P1 by the key matrix, which will give us our first encrypted matrix, E1. Notice how all the numbers inside E1 are greater than 25. This prevents us from converting E1 into letters. In order to solve this, we need to convert E1 into a mod 26 matrix. We do this by dividing each of the numbers by 26 and then using their remainders to make a new matrix. The new matrix using the remainders is 15, 24, and 0. Now that E1 is a mod 26 matrix, we can convert it into letters. 15, 24, and 0 correspond to the letters P, Y, and A. These will be the first 3 letters of our encrypted text. In order to encrypt the rest of the message, we repeat this process for every 3-letter segment for the rest of the plaintext phrase. Okay, pause. You're probably thinking, wow, this is gonna take a really long time, and honestly, you're right. I don't know about you, but I don't have all day to do this much matrix multiplication. I mean, look how long this video is already getting. Luckily for us, we can actually expedite this process using a little bit of programming. In order to do this though, we're gonna have to go into MATLAB. Once inside MATLAB, we create matrices K and P1 and fill them in with their numerical values. We then write a short function called mod26 matrix, which applies mod26 to any matrix we want. In the script, we call this function and use it to apply mod26 to E1. After running the code, we instantly get our mod E1 values. After using the MATLAB code 5 more times for the rest of the plaintext phrase, we finally have a fully encrypted message. Now that we have a fully encrypted message, let's try to decrypt it. Decrypting a Hill cipher is essentially the encryption process, but backwards. All we need to do is multiply the encrypted matrix by the inverse key matrix. However, we need to ensure that the inverse key matrix is still in mod 26. Using the regular inverse would give weird decimal points and wouldn't let us decrypt the message. This MATLAB function called mod inverse matrix will automatically find the inverse key matrix in mod 26. It works by finding the modular inverse of the determinant and then multiplies it by the adjugate. The second part of this function is code that finds the modular inverse. What this does is it converts the determinant to mod 26, which is 21 in this example, and then it finds a value that when multiplied with 21 and converted to mod 26 equals 1. Calling this function along with the earlier mod26 matrix function will give us our original P1 matrix, which is 11, 8, and 13. As you can see, we made a full cycle through the encryption and decryption process. If we continue to do this in 3-letter intervals with the rest of the encrypted phrase, we would get our original plaintext phrase back. That's going to be a wrap on my linear algebra and cryptography project. In our current digital age, cryptography plays a vital role in data security and information processing. I found it really cool how linear algebra concepts could actually be used to protect sensitive information online. Besides its real-world applications, cryptography and cracking codes is just plain fun. To test your decoding abilities, I have hidden letters of an encrypted message throughout this video for you to solve. You need to solve it using a Hill cipher, so here's your key matrix to solve the message. Thank you so much for watching, and I hope you were able to learn something new. Good luck solving, and have an amazing rest of your day.